Good morning, good afternoon, or evening. Okay, as we're popping open the Blackboard this morning, we're looking for our second part on combinations today. The last video there I kind of had some technical difficulties at the back there. So I cut it off at 29 minutes because it kind of got messed up. So we really didn't get into looking at two set problems, which was fine considering that was a 30-minute video anyway. So this one here, we're going to focus specifically on looking at combinations where you have more than one set to choose from or two different distinct sets that you're picking from. And then we'll be also looking at certain examples that also choose from cases, or you have particular cases or limitations on your question. Okay, so those are the two things we're going to look at today. So we'll outline that here at the beginning. So let's type that in here on day 11 of our probability unit and counting unit, still in the counting section. Okay, so this is a day 11, unit 3. Okay, and we're going to be looking at today, we're going to be looking at problems or combinations of problems with more, or from two sets, we'll say. It's not three sets, but it's only two, from two sets of objects. And then we're going to also look at combination problems with cases involved or limitations. So that's what we're going to look at today. It should be, so today we'll do the practice part probably for that section. It's section 4.6 in our text book mainly. And so we'll get a chance to take a look at that this afternoon. And then probably what we'll do after that in our last section, accounting, is kind of when you get all the blended stuff together, which makes it more difficult because you've got to look at combinations, permutations, and decide which one is which and why, and that kind of thing. So the first thing we're going to look at this morning, or today, is combination problems from two sets. Okay, so let's start off with an example. That's probably the best way to get us started. So let's say that we're playing a mixed team of some sport. Let's go with volleyball since I did a lot of coaching on that. So let's say a volleyball team is formed from a group of 4 boys and 4 boys. I got 5 there. Sorry, 5 boys and 4 girls. We'll go with, since I started with 5. Okay, so that they're distinct. Okay. Okay, we'll start off with a basic question first of all. How many teams? Okay, so order doesn't matter in which way you're picked. Of 6 players can be formed. Okay, so reading this one, we're looking specifically at just 6 players. It doesn't matter whether it's a boy or a girl on court. It's just asking for 6 players. So there's no real limitations on this. So we have to look at this as a pool of 9 players picking 6 because there's no limitations. It doesn't say how many ways can you pick this, that, or the other thing. Okay, so this would be one where even though there's 2 sets there, there's no limitations on it because there's no particular statement saying how well, we want 3 girls and 3 boys or something like that. Okay, so this one here, let's get into my marker here, get that set up. Oops. So this one would just be picking 6 players from 9 in a combination because order doesn't matter. So if you're picked first or sixth, you're still on the floor. Okay? Okay, so then we would go, okay, well, we got a group of 9 from 6. Okay, so if we remember the combination formula, let's get rid of that out of there. There we go. The combination formula is, okay, let's write it out first. Today we n over n minus r factorial. And then we have the extra r factorial in there like that. Okay, so in our case, we're picking from 9 minus 6 over 6 factorial. So 9 over 3 factorial, 6 factorial. So we can do some reducing if we want, or we can take out our calculator and use the combination button. So clear that. Okay, so let's go 9 combination 6 on the calculator. And then we get 84 ways, or 84 different teams. That's a total way that we can field, no matter if any limitations at all, that's a total way we can field a team of players that are 6 from the 9. Okay. How about if we get some limitations? So let's throw in now, okay, that was what we were doing yesterday, kind of. Let's throw in some limitations now based on whether you have a boy or a girl. And then we'll also throw in some limitations based on cases as well. So let's say, how many ways can we have 3 girls and 3 boys on the court? Okay, so say you have to have even numbers. Okay, so let's do B here. Whoops. Let's get there we go. B. How many combinations of 3 boys and 3 girls can be fielded on the court are there? Question mark. Okay, so let's say the limitation was they have to have even numbers. Okay. Okay, well, this would be, let's move it up a little bit. Okay, so you would have to look at what your original situation was. You had 5 boys to begin with, and you're going to pick 3, and, because it's a counting principle, and you're going to pick 3 girls from 4. Okay, so because it's got an and in there, we're going to multiply the two combination answers together to get the total number of ways. We're going to pick 3 boys from 5, and we're going to pick 3 girls from 4. So let's write that in. We're going to pick 3 boys from 5, and we're also going to pick 3 girls from 4. Okay, so if we're picking 3 boys from 5, it's 3C5, or 5C3, pardon me. 5 boys picked from 3, and means multiply. We're also going to pick 3 girls from a total of 4. So it's going to be the product of these two numbers. So this is the number of ways you can pick the boys. This is the number of ways you can pick the girls. And the counting principle that we learned about in the very first unit of this unit, very first day of this unit, says that when you are doing two events together and they're together at the same time, then the product of those two events gives you the total number of ways that they can be arranged or combined in this case. So 5C3, we'll do that underneath here. So that's just 5 factorial over 5 minus 3 factorial, 3 factorial, times 4 factorial times 4 minus 3 factorial over 3 factorial. Okay, so this would be 5 factorial over 3 factorial, 2 factorial times 4 factorial over 1 factorial, 3 factorial. Okay, we can work them out then, or we could just use our calculators for each of these. I like to write out the first couple of steps to show that I know what I'm doing. Okay, and we're just going to go 5C3, which give us 10, which makes sense because this would be 5 and 4 divided by 2. 5 and 4 divided by 2 is 20 divided by 2 is 10. And this one here is just going to be 4 because we have 4C3 being 4 over combination 3. Factorial 1 is 1. Factorial 3 is 3, 2, 1. This one's 4, 3, 2, 1. So if you, then you just multiply the two together to get 40 ways. So there's 40 ways you can put 3 boys and 3 girls on the court at the same time, where order doesn't matter, whether you pick them first or second. Okay? You know, it could be anything. When it specifically says something like that, 3 boys and 3 girls, then you have a specific case that you're looking at, one single case there. Okay, you can get problems that also have a particular case on. You have to look at different cases where cases are added together. So that's the third type of problem that can show up here in this problem. Let's do that on the next page. It looks like we're running out of space here. Okay, so let's do an example of let's do it on the next page here. Let's extend it here. Before we do cases, let's throw another one up there, get you to do it. So let's say to see how many ways can there be 4 boys and 2 girls on court. Okay. So you can pause it there, give it a try. Okay, it's similar to B. And then I think we'll set up a new problem for cases. So give it a pause, try that out, and then we'll work it out. Okay, 4 boys. So we have a total of 5 boys, and we're picking 4. Order not mattering, so we're using combination. And then we're going to pick 2 girls from 4. Okay, so there's our 2 girls from 4, 4 boys from 5. Okay, so we're still using the 5 boys and 4 girls from in the first problem. Oops, went too far there. So this one's going to be 5 over 5 minus 4, 4 factorial, times 4 over 4 minus 2, 2 factorial. Okay, so this one here obviously is going to be 5, 4, 3, 2, 1. Then this one's going to be 1, and this one's going to be 4. So we're just going to have 5 there. Okay, this one here, we work that one out. 4 factorial, 2 factorial over 2 factorial. So if you think about it, this is like 2, 1, 2, 1, so that's 4. So we can remove the 4, it's going to be 4, 3, 2, 1. So 3 times 2 times 1. 3 times 2 times 1 is 6. Equals 30 ways. Okay, so there's 30 ways we can have 4 boys and 2 girls on the court. Okay, of course, I like to see, at least one step drawn when you're doing these, but you can go ahead and use the calculator if you want to go like 4C2 and work it out like that and get your answer like that. I'm fine with that. I prefer to see at least you write the formula and then put in your answers. Then if there's a mistake in a button push, I look up here and go, okay, well, they got the right formula. They got the right statement, then they got the right formula, but they made a mistake in the button push. So it's a good idea to have at least a step or two in there. Okay, so that's combinations from multiple sets. Okay, the other thing that we want to look at, if we look back here at the beginning, is combination problems with cases and limitations. So when we have some ors in there. So I'm going to set up a different problem for that, and we'll title that up here. Okay, so let's go with some examples of combination problems with cases / limitations, or limits put on them. Okay, so let's set up a similar problem. Let's set up two sets of objects again. So let's go with let's say 6 cats. We'll go cats and dogs. 6 cats and 5 dogs live in a farmyard, let's say. So, okay. You are going to give away, let's say you are giving, let's get a capital on that. You are going to give away 7 animals. Okay, how many ways can you give away 7 animals so that at least 3 cats are given away? Okay, so we have to think about the problem before we get started on it. So first thing we know is we've got a set of 11 animals and we're giving away 7. Okay, and the animals are dogs or cats. Okay, and we want to give away at least 3 cats. So at least 3 cats means that you can give away more than 3 cats. So you can give away. So let's look at all the particular cases that you can have. Okay, so let's just write them out. Okay, so let me go back to the marker here. Hopefully it's still, there we go. Okay, so the first thing is you can give away at least 3 cats. So let's say a minimum of 3 cats. So you can give away, in our first case, you can give away 3 cats and 4 dogs. Or if you don't do that, so no, it's not and, it's or. That gives you 3 cats. So what if you give away 4 cats? 4 cats and 3 dogs. Notice there's an and in there, and then there's ors here. Okay, what about number 3? What about the last case that I could do? So I could give not the last case, I guess second last case, because I could give away 5 cats. Or, I forgot the or in there. Give away 5 cats and 2 dogs. Okay, or the last case that I could have, I could give away all the cats. Six cats and a dog. So there are 4 particular cases. You might give away 6 cats and a dog, 5 cats and 2 dogs, or 4 cats and 3 dogs, or 3 cats and 4 dogs. So now we have to take a look at what is the combinations that we're doing. Okay, remembering that we had to start with 6 cats and 5 dogs. Okay, so we're going to be picking from the cats and picking from the dogs. So in the first case, we are picking 3 cats from 6 and 4 dogs from 5. Okay, plus for the or, okay, or you may have to pick 4 cats from 6 and 3 dogs from 5. Okay, or you might pick the third case, 5 cats from 6. Okay, and then if we did that, we had 2 dogs from 5. And then, of course, the last choice you may have, or you might actually pick to give away at least 3 cats. You might give the whole bunch away, 6 cats from 6. Usually only one way to pick that, right? And 1 dog. So what was the dogs? 5 dogs. Okay, so let's get our totals from these. So I'm going to use some of the calculation, or I'm going to use a combination calculation here to do this one. Okay, so 6 from 3 and 5 from 4 so that ends up giving us 20 for 6 combination 3 times 5 for 5 combination 4. So we've got on the very top one, we've got 100 ways. Okay, so there's 100 combos of getting 3 cats and 4 dogs. Okay, let me just check the 6 combo 3 because I did that one in my brain. Sometimes it's not. It's at 20. Good. Okay, so then we do the same thing here for this one. 6 over 6 minus 4. 4. Okay, this one's 5 over 5 minus 3. 3. Okay, so this one ends up being 15 for 6C4 times 4 for 5C3. Oops, I was going to put an exclamation mark there. We don't need that. Okay, 15 times 4, or sorry, what is it? That's not 4, that's 10. 4 was the good thing. That's 10 because this would be 5 times 4 divided by, and this one would be 2. So yeah, so that's 10. Let me double check to make sure that 5C3. Yep, okay. So that's 150 combos. Okay, now we've got to look at 5 cats and 2 dogs. So this is 6 over 6 minus 5. 5 combos, so that's going to be 6 for the answer. 5C2. 5C2. So this is going to be 5 and 4, again, divided by 2. So that'll be 10. So this will be 6 times 10. 60 combos. Of that particular case, 5 cats and 2 dogs. Okay. The last one, let's move that up a little bit so we can see a little better. Okay, the last one is 6C6, so that should be 1. If you think about it, so it's 6 minus 6 over 6. So that's going to be 1. And then this one's going to be 5C1. Which is going to be 5. So this is going to be 1 times 5 equals 5 combos. So there's 5 combos for the last case, 60 combos for the third case. Second case was 150 combos and 100 combos. So we've got to add all these combos together because it's or in between. It's this, or this, or this, or this. It's not them all together at the same time. This one could happen, or you could pick this, or you could pick that, or you could pick this. So if you go 100 times 150 times 60, so that's, or not times, plus 100 plus 150, that's 250, plus 60 is 310, plus 5 is 315 ways. So 315 ways or combinations of picking at least three cats to give away in your 7 group. Okay, so that's a particular type of question where you have cases in there. Okay, so let me take a look at the clock here. It's 28 minutes. Okay, so yesterday we didn't do any practice, so we'll stop at that point and give out some practice problems that use some cases and use some of the, let's get that out of the way here. There we go. Use some cases and use some basic combination problems in 4.6. So let's kind of look at page 280, 281. And let me just pause it here and take a look and make sure I don't give you some weird ones here. I'll give you some ones that we've kind of looked at for examples here. So I'll just pause it there and then I'll unpause with what I want. Okay, so we should be able to handle all of these, 1, 4, 5, 6, 8, and 11. Keep in mind, just before I let you go here this morning, if they do combinations with brackets around it like this, say something like 7 and 4 here, that's equivalent to saying 7C4. So don't forget about some of them there in question number 4 have brackets in there. Okay, so good luck. Give those a try. And next day we'll be looking at the blended problems that can happen.